Hello everyone. Today we are going to discuss atomic structure from state board syllabus. Okay. So in atomic structure, the important topic is what? Electromagnetic spectrum. So electromagnetic radiations are what? Cosmic rays, gamma rays, X-rays, ultraviolet radiations, visible radiations, infrared radiations, microwaves, and radio waves. These are important electromagnetic radiations. Electromagnetic radiations meaning what? The radiations which are associated with oscillating electric field and oscillating magnetic field, which are perpendicular to each other and also perpendicular to direction of propagation. So both electric and magnetic fields are perpendicular to each other and also perpendicular to direction of propagation of the radiation. So that is what now electromagnetic radiation. So all electromagnetic radiations have most of the properties in common and some different properties will be there. So the wave characteristics we can understand. So every electromagnetic wave is associated with some characteristic properties called what? Wave properties. Okay, ma? So that we are going to discuss. Now cosmic rays have highest energy radiations. They are what? Highest energy radiations. They have highest energy among all the electromagnetic radiations. Highest energy. Highest energy will be there. Highest frequency will be there. Highest wave number will be there. So E is what? Energy. Nu, nu is frequency. Nu bar is wave number. So energy is highest, frequency is highest, nu bar wave number is highest. So these three are always directly proportional to each other. These three wave characteristics. That's why the cosmic rays have highest energy, highest frequency, and highest value of the wave number. So that one keep in mind. And they will have smallest means shortest lambda. Lambda is what here? Wavelength. Wavelength is shortest. For cosmic rays, the wavelength is what? Shortest, whereas energy, frequency, and nu bar wave number are what? Highest values. And similarly, lastly, what is the here? Radio waves there here. These radio waves have what? Longest wavelength. Longest wavelength. Whenever wavelength is longest, what will be less? Therefore, least energy, least frequency, and least value of wave number. Okay. So for the radio waves, what will be least more? Least energy, least frequency, least wave number will be there. Nu bar indicates what? Your wave number. So longest wavelength will be there for radio waves. That means what? What is the wavelength here between one crust and trough? Okay. So this is peak, wave peak, crust, and it is trough. Okay. So now here between crust and crust, the distance is called what more? Lambda, wavelength. The distance between trough and trough or crust and immediately next crust. Between two successive crusts or between two successive troughs, the distance is called what? Lambda. Between one crust and next trough, suppose. Between one crust and next trough, the distance is lambda by 2. Between trough and trough or crust and crust, the distance is called what? Lambda. Between one crust and immediately next trough, crust and trough, the distance is called here lambda by 2. Remember. So here, the longest wavelength electromagnetic radiations are what? Radio waves. That's why they have least energy, least frequency, least value of nu bar, wave number. Now, how you can say, what you can say relation between energy and radiation? Energy and wavelength, how to say here? Inversely proportional. So this wavelength is inversely proportional to energy of radiation, frequency of radiation, and wave number of radiation. Okay. So the equation called what? Planck's equation explains what the relationship between all these here. Planck's equation. So what is now here? Before going to that Planck's equation, and also underline here ultraviolet radiations, visible radiations, infrared radiations. Among these three, ultraviolet radiations have more energy than visible. Visible have more energy than infrared radiations. Now visible light again is sensitive to human eye. We can see directly only visible light. Again, this visible light is what here? Composed of different colors. When you pass the visible light through the spectrum, okay, through what? A prism, okay, through spectrometer or prism, if you pass what? visible light, it will be dispersed. The visible light will be dispersed into how many colors? 7 colors. They are what? Vibgyor colors. VIBGYOR. Violet, indigo, blue, green, yellow, orange, red. Among these 7 colors, violet has what? Highest energy. Highest energy. So highest energy, frequency, nu bar. These 3 will be highest for what? Violet. And red will have what now? Least energy, frequency, wave number. These values will be least for what? Red. So whenever these values are least, what will be more? Longest wavelength. Longest wavelength for red. So among the Vibgyor colors of visible light, the red will have what? Longest wavelength, whereas energy will be least, frequency will be least, and wave number will be least. And violet has what? Highest energy, meaning what? Shortest wavelength. Shortest wavelength for violet. It is only what here among these visible radiations, among the different colors of what? Visible light. Okay. So now among the all electromagnetic radiations, which will have longest wavelength, radio waves have longest wavelength. As wavelength is longest, we have less energy, less frequency, and less wave number. Okay, ma. So now next thing is that Planck's equation. What is that? Planck's equation. So Max Planck gave an equation called what? Planck's equation. So this Planck's equation is given by what? E is equal to H nu. E is equal to what, ma? H nu. So in place of nu, what we can write? C by lambda. So Hc by lambda. So nu is equal to what? Nu is equal to C by lambda. So in place of H nu, what we can write? H C by lambda. C is what? Velocity of light. Lambda is the wavelength. And H is what? Planck's constant. And also remember that the nu bar wave number is nothing but, generally wave number, this wave number nu bar is nothing but 1 by lambda. What is nu bar equals to here? Wave number is equal to inverse of lambda. That is reciprocal of wavelength. Reciprocal of wavelength is called what, ma? Wave number. So wave number nu bar is equal to always what? 1 by lambda. So in place of 1 by lambda, what we can write? Nu bar we can write. So in place of 1 by lambda, what we can write, ma? Nu bar. So that is equal to H C nu bar. So H C nu bar is what now here? The formula for energy. So energy of any radiation, energy of violet color, energy of red color, or energy of gamma radiation, energy of X-rays, anything will be equal to what? H into nu is equal to Hc by lambda. Hc by lambda, that is equal to Hc nu bar. Hc nu bar. So this is what now here Planck's equation. So this Planck's equation is applicable for all the types of waves. Okay, ma'am? So it's about what now here? Max Planck's equation. Max Planck's equation. So what will be the units of what energy here? Joules and what here? Ergs. Joules what here? MKS units. Ergs what? CGS units. Now what will be H value? We have to remember. What is important thing is that H value. The H is what now here? Planck's constant. What is H one? Planck's constant. So what is the value of Planck's constant? Numerical value of Planck's constant what? 6.625 into 10 to the power of minus 34 joule into second. Joule second. It's not joule per second. It's not joule per second. It is joule into second. So joule second you read. So what here? 6.625 into 10 to the power of minus 34 joule second is the value, numerical value of what? H. H is what? Planck's constant. And we also know that 1 joule equals to what? 10 power 7 ergs. 1 joule equals to 10 power 7 ergs. So in place of joule, what we can write? 10 power 7 we can write. 10 power 7 into 10 power minus 34. It is 10 power minus 27. So the same value we can write in erg also. So 6.625 into 10 to the power of minus 27 erg second. Erg second. Erg is what now? Erg second is what? CGS unit of H, Planck's constant. Joule second is what? MKS unit of Planck's constant. So these numerical values we must remember. So E is what? Energy in joules, and H value Planck's constant. If you take H value in joule second, we get energy in joules. If you take H value in erg second, we get energy in ergs. Okay, so the units must be taken care of. All should be in the same system of units. All should be taken in same system of units. And what is the units of what is the unit of frequency generally? Frequency is measured in what? Hertz. Hertz. This is also called second inverse per second. Hertz means what? Second inverse. So hertz, otherwise second inverse will be units of what? Frequency. Frequency. And nu bar. Nu bar means what? Here wave number. The nu bar units will be what? Nu bar 1 by lambda. Na? 1 by lambda means 1 by centimeter. 1 by centimeter or 1 by meter. That means what? Centimeter inverse or meter inverse we take. Centimeter inverse or meter inverse will be what now? Units of nu bar. Nu bar means wave number. Wave number is equal to what? 1 by lambda. 1 by lambda means 1 by meter or 1 by centimeter. So we take what? Meter inverse, centimeter inverse as the units of what? Nu bar. Nu frequency will be having units of what? Hertz. That is second inverse. Energy will be measured in what? Energy will be measured in joules or ergs. And the units of H will be joule second in SI and in CGS erg second. Erg into second. So these are what important areas related to what? Electromagnetic radiations. And what are these colors called here? Rainbow colors we say. What we say? Rainbow colors. If you observe the rainbow, all these colors are merged with one another. There is no gap between one color and the other color. As there is no gap between one color to other color, okay, this type of spectrum is called what? Continuous spectrum. Spectrum meaning what? The group of different wavelengths. Now every color has its own wavelength. Every color has its own frequency. Now group of 7 colors meaning what? Group of 7 wavelengths we can say, or group of different frequencies we can say. Group of 7 frequencies or group of 7 wavelengths. So group of wavelengths, group of different wavelengths or group of different frequencies is called what? Spectrum. And this spectrum is what? VIBGR is what now? Visible light spectrum. The spectrum obtained from visible light. When visible light is passed through prism, the visible light undergoes dispersion. Dispersion of white light takes place to get what? 7 colors. The record of 7 colors. Okay, if you record the 7 colors on one plate, photographic plate, that record is called what now? The graph is called what now? Spectrum. So spectrograph we say. What we say? What we get 7 colors, the combination of 7 colors on the photographic plate is called what? Spectrograph. To get the spectrum, we use one meter called spectrometer. In spectrometer, what will be there? Prism will be there. Okay, so white light undergoes dispersion to give 7 colors. The group of 7 colors is called what? A spectrum. That one keep in mind. Next one, a spectrum. This spectrum is obtained from visible light. And how visible light is obtained? By the emission of sun. Okay, so by the emission of sun, what we got? From sun, some light is emitted, white light is emitted. That emitted white light is used to get this spectrum, to get VIBGR spectrum. What we used? Some light emitted from sun. That is visible light emitted from sun we used here. So this type of spectrum obtained is called emission spectrum. Emission spectrum. Why we are saying emission spectrum here? Because this spectrum is obtained from emitted light from source. Source is what here? Sun. So when you take tube light, the light of tube light, white light of tube light, when we pass through prism also we get what? 7 colors. Here also we used what? The light emitted from tube light. That means the emitted light is used here. So this spectrum is called emission spectrum. The emission spectrum we say, and also it is continuous spectrum. Continuous spectrum. That one keep in mind. And also remember that whenever you take sodium spectrum, in case of sodium spectrum, if we pass white light through sodium vapors, some device we take here, this sodium vapor is there. Through this sodium vapor, we are passing what? White light. This white light, when you pass through this what here? Sodium vapor, the light coming out is called transmitted light. What is this light called? Transmitted light. The light which is passed through this vapor is coming out now here from the vapor. This coming out light is called what? Transmitted light. This transmitted light will be allowed to fall on prism. This transmitted light is passed through prism. Then we get some spectrum, different lines we get. That spectrum is called what now? Absorption spectrum. Absorption spectrum means when you pass white light, out of 7 colors of white light, out of which are colors, 1 color is absorbed by sodium vapor. Suppose generally sodium vapor absorbs yellow color. Remember, the sodium vapor absorbs what? Yellow color. Now when you record this graph here, when you record the spectrum of the lines of sodium vapor, we get what now here? Dark line somewhere here. The missing lines will be there. Suppose yellow color is missed. In place of yellow color, what will be there? Some dark line will be formed. Okay, 1 color is absorbed by sodium vapor now. By absorption, what happens there in the spectrum? In the place of yellow, what will be there? 1 dark line will be absorbed here. That is missing light. So here, this type of spectrum obtained is called what now? Absorption spectrum. Absorption spectrum. In sodium vapor spectrum, in sodium absorption spectrum, we get 2 lines. 2 lines will be there here. Okay, 2 dark lines will be observed here. So these 2 lines are called D1, D2 line. What are the 2 lines called here? D1, D2 lines. Okay, so these D1, D2 lines, 2 lines means the group of 2 lines is called doublet. D-O-U-B-L-E-T. Doublet means what here? The group of 2 lines. The group of 2 lines will be observed in absorption spectrum of sodium. D1 line, D2 line. D1, D2 lines will be having different wavelengths. Lambda 1 for D1 line, lambda 2 for D2 line. 2 lines will be observed here. Okay, the group of 2 lines in the sodium spectrum is called what? Sodium absorption spectrum is called doublet. The closely spaced 2 lines together called what? Doublet. Okay, so why 2 lines observed here in sodium is that in sodium, in the outermost orbit, how many valence electrons are there? Only 1 valence electron. Sodium atomic number 11. 1s2, 2s2, 2p6, 3s1. 3s1 is what? Outermost electron. 1 outermost electron is there. In s orbital, 1 box, 1 electron is there, clockwise spinning. In 1 orbital, 3s orbital, in 1 box, if 1 electron is there, that 1 electron may be rotating clockwise in clockwise direction or may be rotating in anti-clockwise direction. So the rotation may be clockwise or anti-clockwise. Remember, clockwise direction will be there, anti-clockwise direction will be there. If only 1 electron is there in the orbital, that is unpaired electron we say, unpaired electron. That unpaired electron may get clockwise spinning or anti-clockwise spinning. Spinning means what here? Rotation. Okay, so like this here, whenever it is rotating clockwise,ly it will be giving 1 line. When it is rotating anti-clockwise,ly it will be giving other line. So why 2 lines observed here in the absorption spectrum of sodium? Because 1 electron in the outermost orbit may be having clockwise spinning or anti-clockwise spinning. So that we have understood that the spinning of electron will be of 2 types. Clockwise spinning will be there, anti-clockwise spinning will be there. So from this concept of sodium spectrum, sodium vapor spectrum of absorption type, we have introduced what now? Spin quantum number. The scientists have introduced what? Spin quantum number, 4th type of quantum number, from the concept of what? The sodium absorption spectrum. Why this spectrum is called absorption spectrum? We have passed the transmitted light through prism, not white light directly through the prism. White light is passed through vapor, sodium vapor. Sodium vapor absorbed yellow light. After that, some light is coming out. This is called what now? Transmitted light. This transmitted light is used here to get the spectrum. So the sodium spectrum here is called what now? Absorption spectrum. Okay, ma. So spectra will be of how many types? 2 types. Spectrum singular, spectra plural. How many types of spectra we have? 2 types. Emission spectrum, absorption spectrum. Here sodium vapor spectrum is example for what? Absorption spectrum. And here this VIBGYOR is what? Emission spectrum. 2 types of spectra will be there. That point keep in mind. Next one is that in this sodium spectrum, between D1 line, D2 line, there will be some gap, remember. Between D1 dark line, D2 dark line, okay, there will be some gap. There is some gap between the 2 lines, 2 wavelengths, lambda 1, lambda 2 lines. 2 lines with 2 different wavelengths. Group of two different wavelengths is called spectrum. Group of wavelengths is called spectrum. Like that, in absorption spectrum of sodium, between D1 line with the lambda 1 wavelength and D2 line with the lambda 2 wavelength, there is some gap. So this type of spectrum is called discontinuous spectrum. Is it continuous or discontinuous? Discontinuous spectrum, because there is a gap between D1 line and D2 line of sodium absorption spectrum. So that point mainly we have to keep in mind. Okay, so sodium absorption spectrum is what? Absorption type and discontinuous spectrum, remember. Okay, so next, here emission spectrum, VIBGYOR is an example of what? Emission and continuous. Why it is continuous spectrum? One color is merged with other. One color is merged with other color. We cannot see any gap between one color and other color in VIBGYOR spectrum, in rainbow. That is why it is called what, ma? Continuous emission spectrum. And sodium absorption spectrum is an example of what? Discontinuous absorption spectrum. And in sodium absorption spectrum, what I told you, dark line will be observed, or what here? Bright line will be observed, dark line will be observed. In which one? Absorption spectrum. So remember that in absorption spectrum, always which lines will be observed? Which lines? Which spectral lines? Dark spectral lines. Dark spectral lines. To observe the dark spectral lines, the background should be bright or dark. The background should be bright. So in case of absorption spectrum, which lines are observed? Dark lines. To record the dark lines, the background must be what? Photographic plate. Background should be what? Bright. So remember that in absorption spectrum, dark lines are observed on bright background. So that point is very important here. Okay, just you note down. In absorption spectrum, dark lines are recorded on bright background. Bright background. Okay. Now, for emission spectrum, reverse now. For emission spectrum, reverse. Now, see here, when white light emitted from sun, passed through prism, then we got different colors here. Spectrum we got, VIBGYOR spectrum we got. In this spectrum, every line we see bright line, violet, bright color line, red, bright line. So all these 7 colors are what? 7 bright lines, suppose. Now in emission spectrum, which type of lines? Bright lines will be there. To record the bright line, we should use background what? Dark background. Okay, ma. So in emission spectrum, background should be dark. As spectral lines observed are what? As spectral lines obtained are what? Bright. So in emission spectrum, bright lines are observed on dark background. So this point is not to be confused. Okay. So 2 types of spectra: emission, absorption. And remember that absorption spectrum is always discontinuous spectrum. Absorption spectrum is always what? Discontinuous spectrum. Means there will be gap between one spectral line and other spectral line of absorption spectrum. So it must be only discontinuous absorption, that's all, one type only. But in emission spectrum, here it is what now? Emission continuous. Emission continuous. But if you take hydrogen spectrum, hydrogen spectrum, in hydrogen spectrum, there will be Lyman series lines, Balmer series, Paschen series, Brackett series, Fund series, Humphreys series. There are different series of lines in hydrogen spectrum. So when you heat the hydrogen gas, we get some emitted light. When we heat the hydrogen gas, some light is emitted. This emitted light from hydrogen gas is passed through prism. Then we get lines, different lines, Lyman, Balmer, Paschen, Brackett, Fund, different lines we get. Okay. Now between one line, other line, there will be gap, remember. There will be some gap between one line and other line of hydrogen spectrum. That is what now hydrogen spectrum is: discontinuous spectrum or continuous spectrum. It is discontinuous. There is gap between one line, other line. That's why it is continuous or discontinuous. Hydrogen spectrum, discontinuous. And that hydrogen spectrum is obtained from emitted line or not? Emitted light or not? From hydrogen gas, we got some emitted light. So emitted light is used from hydrogen gas. So that is emission spectrum, remember. So hydrogen gas is what? Emission spectrum, and discontinuous spectrum. But Whittier is what? Emission spectrum, continuous spectrum here. So in this way, what we can say now, emission spectrum is of two types. Emission spectrum is of two types. What are they? Continuous emission, discontinuous emission. Continuous emission example what? Continuous emission spectrum example what? Whittier. Discontinuous emission spectrum example what? Hydrogen spectrum. Is that clear, ma? Next, absorption spectrum. Only one type will be there. Discontinuous absorption spectrum. That's all. Example what? Sodium spectrum. Sodium absorption spectrum. So these all are important points to be remembered. Okay, ma? So it's about what now here? Different types of spectra of hydrogen atom and electromagnetic spectrum. The next we study about flame colors, and also Bohr's atomic model. Okay, ma? Bye, good day.